myself B. Praveena. I am the Assistant Professor of Mathematics in Institute of Aeronautical Engineering College. Today I want to discuss about the rank of a matrix. Already I discussed in the previous class basic definitions of the matrices. Now I'll discuss that basic concept of the rank of a matrix and echelon form. Okay, before going through that rank of a matrix, first I'll discuss with the elementary row and column operations. Elementary row and column operations. Okay, once observe there, let R1, R2 and so on, Rn be the rows of a matrix A of order m by n, and C1, C2 and Cn be the column vectors of A. Here these are rows vectors of matrix and order m by n, and C1, C2 and so on Cn be the column vectors of A. Okay, then elementary row operations of A is of any one of the following three operations of the transformation. First I'll discuss with the row transformations. Okay, from that first point of the row transformations, the interchange of any two rows. The interchange of any two rows. And the second point, multiplication of a row by a non-zero scalar k. The interchange of any rows means that is R1, either R1 to R2 or R2 to R1. And if you are multiplying with the row with any non-zero scalar k, means we have to multiply with a into k into R1. And the next point, replace a row by adding to itself any non-zero scalar multiple of any other row. Once again, replace a row by adding to itself any non-zero scalar multiple of any other row. Now I'll discuss with the 3 points with the notations. Okay, here the notations are there in the 3 points. That is, the notations we shall follow for these 3 elementary row operations is as follows. The first transformation for that, interchange of ith and jth row is denoted by R1 interchanges to Ri interchanges to Rj. Already I discussed in the previous slide that notation as interchange any rows with respect to here I and j, or R1 interchanges to R2. Here I'll interchange Ri interchanges to Rj. And the next transformation, multiplication of ith row by a non-zero scalar k. If you are multiplying with any scalar k is denoted by, okay, if you are multiplying with any scalar k with the given row operation, then how to write that? That is Ri interchanges, tends to k into Ri. That means what? That row is multiplied with one non-zero scalar, that is k. And the next, third one, addition of k times of the jth row to the ith row is denoted by addition of k times the jth row to the ith row is denoted by. Once here observe that row operation, addition of the kth row, that means k into Rj. Here Rj row is multiplied with the k, that is adding with what? Ri. Okay, Ri is adding with, okay, multiplication with k with Rj row. Okay, then that row operation as Ri tends to Ri plus k into Rj. These are the 3 notations for the row operations. Okay, similarly we will discuss with the same concept with the column operations. Okay, similarly, we can define an elementary column operations of A as one of the following 3 operations. For the first one, the interchange of any 2 columns. Okay, same as row transformation here, we have to apply the same conditions for the columns also. There, the first condition is interchange of any 2 columns. And the second point, multiplication of a column by a non-zero scalar k. Okay, here we have to multiply with any column with that k scalar. And the third point, replace a column by adding to itself any non-zero scalar multiple of any other column. Okay, once observe there, replace a column by adding to itself any non-zero scalar multiple of any other column. Okay, now we will discuss with these three notations in the next slide. Okay, that is the notations we shall follow for these three elementary column operations is as follows. Okay, first one, okay, interchange the ith and jth column is denoted by C1 interchanges to Ci interchanges to Cj or Cj interchanges to Ci. That is the notation for the first point. And the next one, multiplication of ith column by a non-zero scalar k will be denoted by Ci tends to Ck into Ci. Once observe there, here multiplication of the ith column by a non-zero scalar k will be denoted by Ci tends to k into Ci. That means what? One column is multiplied with one non-zero scalar. We have to write that as k into Ci. Okay. Next, what about the third point? Addition of k times the jth column to the ith column will be denoted by addition of k times the jth column to the ith column will be denoted by. That means here once observe the jth column of jth column is multiplied with what? K. Okay, jth column is multiplied with k and adding with some other column, that is Ci. Okay, then the changes in where the changes, that is Ci. That means Ci changes to Ci plus that column is adding with k into another column Cj. Okay, these are the basic three notations for the columns and rows. Okay, next. Okay, after this, after learning this row transformation and column transformations, okay, we will discuss about the rank of a matrix. If you know that transformations thoroughly, okay, easily we can get the rank of a matrix problems. Okay, first I'll discuss with the rank of a matrix with the basic concept. Okay, with the basic concept. Okay, what is rank of a matrix? First listen that is, let A be a m by n matrix. Okay, that A be a m by n matrix. If A is a null matrix, we will define its rank to be 0. If the matrix A be m by n matrix, if it is null means directly that rank to be what? 0. Okay, if A is a non-zero matrix, we say that the rank is R is the rank of A. Okay, if A is a non-zero matrix, we say that small r is the rank of A. Okay, if the matrix is null, for that case directly that rank is equal to 0. Okay, if A is a non-zero matrix, we have to follow the some conditions for finding the rank of R. Okay, what is the first condition here? Every R plus 1th order minor of A is 0. Every R plus 1th order minor of A is 0. Next condition, at least one rth order minor of A which is not 0. At least one rth order minor of A which is not 0. Then we have to consider that order as the rank of a matrix. Okay, simply here for example, every r plus 1th order minor of A is 0. That means for the 2 by 2 matrix, for the 2 by 2 matrix, if you are finding that order minor of A is 0, means first find out the det value for the 2 by 2 matrix. If the det A is equal to 0, Okay, that is not the rank of the, that order is not a order of the rank of the matrix. Okay, at least one order minor of A which is not equal to 0, where that order of the minor which the determinant A is not equal to 0, we have to consider that order as the rank of a matrix. If it is 0, then no need to consider that order as rank of a matrix. Where the determinant is not equal to 0, we have to consider that order as the rank of a matrix, that is R. Okay, it is denoted by row of A. Simply I'll explain. For the given matrix where the determinant of A not equal to 0, okay, that corresponding order as the rank of a matrix. If that order is that the given matrix det A is equal to 0, then that is not a rank of the matrix. Simply where the det A is not equal to 0, that corresponding order as the rank of a matrix. Now I'll discuss with some examples for the rank of a matrix. Before going through that example, first we will discuss with some properties for the rank of a matrix. First, what about the first point there? It is denoted by, rank is denoted by what? Row of A or small r. Row of A or small r. Always, what about the second point? Rank of a matrix is unique. Always, any matrix, that rank is unique. And every matrix will have a rank. What about the third point? Every matrix will have a rank. And the fourth point, if A is a matrix of order m by n, then rank of A is equal to minimum of m comma n. This fourth point is very important. Where we can apply this point means there the given matrix is rectangular matrix. For that case, first we have to take the formula for finding the rank of A as minimum of m comma n. Okay, minimum of m comma n. Okay, and the next point, fifth one, if rank of A is equal to R, then every minor of A of order R plus 1 or more is 0. Okay, that is the fifth point. And sixth point, rank of the identity matrix is IN, is N. Okay, here rank of the identity matrix. Identity matrix or unit matrix. What is that? 1 0 0 0 1 0 0 0 1. Directly, if that the matrix is 3 by 3, that rank is directly is equal to how much? That is 3. Okay, therefore that I is equal to what? I3 is equal to 3 for the given matrix. If any identity matrix of order as n, that order n as the rank of the given matrix, always the determinant value is not equal to 0. So that corresponding order as the rank of a matrix. Next, seventh point, if A is a matrix of order n and A is a non-singular, then rank of A is equal to what? N. If A is a matrix of order n and A is a non-singular matrix. What is non-singular? Non-singular means det A not equal to 0. Okay, for that case, that rank is equal to what? N. Okay, this is very important point. Okay, then if A is a matrix of order n and A is a non-singular. Non-singular means what? Det A not equal to 0. Where the det A is not equal to 0, that corresponding order as the rank of a matrix. That is this point. That is rank of A is equal to n. That is rank of A is equal to n. Once again, I'll repeat what is the basic concept of the rank of a matrix through this seventh point. Where the determinant of A is not equal to 0, we have to take that the corresponding order as the rank of a matrix. Here, once you see that identity matrix, this is 3 by 3 matrix. Whatever the determinant of A this determinant is not equal to 0. This determinant is not equal to 0. Therefore, the corresponding order as 3 by 3. Therefore, the rank is equal to what? 3. Okay. This is the important point for the rank. And next, what about the null matrix rank? Null matrix rank is always is equal to 0, and identity matrix rank is always is equal to n. And another main point here, rank of a matrix is always unique, and every matrix will have a rank. And the fourth point, if A is a matrix of order m by n, then rank of A is equal to what? Minimum of m by n. Where this point applicable means, where that if the given matrix as a rectangular matrix, for that case we have to take the formula for finding the rank of A is minimum of m comma n. Okay, we will discuss with one example for finding the rank of a matrix. Then for the first question from the rank of a matrix, that is, find the rank of a given matrix. Okay, find the rank of the given matrix A. Okay, what is the given matrix here? 1, 2, 3, 3, 4, 4, 7, 10, 12. 1, 2, 3, 3, 4, 4, 7, 10 and 12. This is, what about the order of the matrix? This is 3 by 3. This is 3 by 3. First, I'll find out the determinant for the 3 by 3 matrix. For the 3 by 3 matrix. Here, once observe, what about the determinant for the given matrix A? That is 1. Okay, 1, 2, that neglecting that corresponding row and column. That is 1 into 4 into 12, 48, minus 10 into 4, 40. 48 minus 40. And what about the second element in the first row? That is minus 2 into neglecting that corresponding column and row, and remaining we have to take the cross multiplication. That is 12 into 3, 36, minus 7 into 4, 28. Plus, what about the third value in the first row? That is 3. Plus 3 into 30, neglecting the corresponding row and column, and the remaining part we have to take the cross multiplication. That is 10 into 3, 30, minus 7 into 4, 28. Okay, this is det of A. For that, 1 into 48 minus 40. That means what? 48 minus 40 means 8. Minus 2 into 36 minus 28 means how much? That is 8. 8 into 6. Okay, here 1 into 48 minus 40 is 1 into 8 minus 2 into, okay, this is 8. Plus 3 into 30 minus 28 is 2. Okay, then this is 8 minus 16 plus 3 into 2, 6. From that, here 8 plus 6, 14 minus 16. That is minus 2 not equal to 0. That is minus 2 not equal to 0. Therefore, here for the 3 by 3 matrix, we have minor of order 3. That det A value is equal to how much? There, det A not equal to 0. There, det A not equal to 0. Therefore, what about the order of the given matrix? That is 3. Therefore, we have minor of order 3. Therefore, that order as the rank of the given matrix. Therefore, rank of A is equal to what? 3. Therefore, rank of A is equal to 3. Okay, this is the first problem for the basic rank of a matrix. Simply, where the given matrix determinant value is not equal to 0, we have to consider that corresponding order as the rank of a matrix. For the first question, their determinant value is not equal to 0 for the minor of order 3. Therefore, that the rank is equal to 3. And the next question, find the rank of a matrix 1, 2, 3, 4, 5, 6, 7, 8, 8, 7, 0, 5. 1, 2, 3, 4, 5, 6, 7, 8, 8, 7, 0, 5. Okay, once observe, is it rectangular matrix or square matrix? This is rectangular matrix. Okay, this is rectangular matrix. For that, order as 3 by 4. Here, number of rows are 3 and number of columns are 4. Therefore, its rank is equal to, already I discussed in the properties, if the matrix is rectangular, for that case, how to take that rank of a matrix? Through the formula, its rank is equal to minimum of 3, 4. Here number of rows are 3 and the number of columns are 4. Therefore, its rank is equal to minimum of 3, 4. Which is minimum there? 3 as the minimum. Therefore, rank is equal to 3 here. Okay, now I have to test if the rank is 3 means that determinant is equal to 0 or not equal to 0. We will test for that. For that, let us consider the minor of order 3 by 3. Okay, from the formula here we know that the rank of minimum of 3, 4 is 3. From the given question I will take for the 3 by 3 matrix. Okay, then that is let us consider the minor of the matrix for the given, that is 1, 2, 3, 1, 2, 3, 5, 6, 7 and 8, 7, 0. 1, 2, 3, 5, 6, 7 and 8, 7, 0. Now I have to test for the determinant for the minor of order 3. That is, let us consider the minor for this. That is determinant value for that is 1 into 6. Okay, neglecting that corresponding column and row, and the remaining part as take as the cross multiplication, that is 0 minus 49 minus 2 into 0 minus 56 plus 3 into 5 into 7 35 minus 48. Okay, 35 minus 48 plus 3 into neglecting that corresponding row and column and row there, 35 minus 48. From that here 1 into minus 49, here minus 2 into minus 56, that is minus 49, minus into minus plus 2 into 56 as 112, and 3 into 35 minus 48. After subtracting and multiplying with the 3 directly, this is minus 39. Okay, minus 39. After subtracting these 3, that is equal to what? 24. Okay, therefore det A for the minor of order 3, the determinant of value is equal to 0. Okay, if the det A, where the det A not equal to 0 from the condition there for the order of minor 3. Therefore, what about the rank of the given matrix? That is equal to 3. Therefore, the rank of the given matrix is 3. Okay, this is the concept for the rectangular matrix. For example, for the 3 by 3 matrix, if det A is equal to 0, okay, if det A is equal to 0, for that case, we can take for the 2 by 2 minor of order from the given matrix. Okay, but directly here the given question for the 3 by 3 matrix determinant of A not equal to 0. But if it is equal to 0, then go for the 2 by 2 minor of order. We have to test for that determinant, which is not equal to 0 means we have to consider the rank for the given matrix. But for this question here directly minor of order 3, det A not equal to 0, so that we have to consider the matrix order as order means the rank. Here rank is equal to 3. Okay, these are the two questions. One is for the square matrix and another one is the rectangular matrix. The rank always less than or equal to minimum of 3, 4. Okay, next. Okay, these are the basic concepts for the rank. Next, I'll discuss with here after completing for the rank of a matrix. Here next methods for finding the rank of a matrix. Here 3 methods are there in that. First one, okay, rank methods for finding rank methods. Here first one echelon form and another one normal form. Okay, already we discussed with the basic concepts of rank, and after that rank methods are here. 2 methods are there in our syllabus. First one is the echelon form and another one is the normal form. First, I'll discuss with the echelon form of a matrix. This is one of the method for finding the rank of a matrix. Compared to the basic concept of the rank, here we can apply the echelon form for the any matrix. Easily we can get the rank of any matrix. Okay, first I'll discuss with the echelon form of a matrix. Okay, here what about the concept of this? A matrix is said to be in echelon form if a matrix is said to be in echelon form if first point 0 rows if any exist. 0 rows if any exist, they should be below the non-zero row. Okay, this is the first point. And the second point, the first non-zero entry in each 0 row is equal to 1. And the third point, the number of zeros before the first non-zero element in a row is less than the number of such zeros in the next row. Okay, this is the concept for the echelon form. Okay, we will discuss clearly. Okay, a matrix is said to be in echelon form 0 rows. If any exist, they should be below the non-zero row. 0 rows if any exist, they should be below the non-zero row. And the first non-zero entry in each row is equal to 1. And the number of such zeros before the first non-zero element in a row is less than the number of such zeros in the next row. I'll explain with one example. Okay. The number of non-zero rows in echelon form of a matrix is rank of A. Okay. And here once observe the condition 2 is optional from the definition. Okay. What about the second condition there? Here the second condition is the first non-zero entry in each non-zero row is equal to 1. That condition is optional. Okay. That means, okay, therefore, number of non-zero rows is equal to what? Rank of a given matrix. For example, I'll discuss with 1, 2, 3, 0, 3, 1, 0, 0, 1. Okay, this is one echelon form concept. Okay, once observe here the first row first element is 1, but this condition is optional. This condition is optional. Through the definition here once observe number of zeros less than the next row zeros. Okay, if that condition is satisfied, okay, then echelon form condition is satisfied. If the condition is satisfied, number of zeros less than of the next row zeros. If that condition is satisfied means the given matrix is reduced as echelon form. Simply we called this as, okay, reduce the given matrix as upper triangular. Okay, reduce the matrix as upper triangular. What about the basic definition for this? This is the basic concept. Through the definition, simply we have to reduce the matrix as upper triangular. Upper triangular means what? Below the diagonals are zeros. Here what are the diagonal elements? 1, 3, 1, and below the diagonals are equal to zeros. If below the diagonals are zeros, with respect to only apply here the row operations. If the matrix reduced as upper triangular, therefore number of non-zero rows, how many are there? We have to consider that number of non-zero rows are the rank of a matrix. This is the concept of the echelon form. Okay, I'll give one example for that. Okay, find the rank of a matrix 2, 3, 7, 3 minus 2, 4, 1 minus 3, minus 1 by reducing it to echelon form. Okay, what's the concept of the echelon form? Easily reducing the matrix as upper triangular with respect to the row operations. With respect to the row operations. Here, what is the given matrix? 2, 3, 7, 3 minus 2, 4, and 1 minus 3, minus 1. This is the given matrix. I am applying the row operations for that. Okay, once observe through the definition, what about the second condition? If first row first element is equal to 1. Once observe the first row, there is first element is equal to 1? No. But possibility is there in the third row. So that I'll interchange the rows. Okay, first I'll interchange the rows. That is R1 interchanges to R3. That is 1 minus 3 minus 1, 3 minus 2, 4, and 2, 3, 7. After interchanging the rows, that the condition is satisfied there, but that condition is optional, but here the possibility is there, that's why I'll interchange the rows. Okay, na? Here through the definition that the condition 2 is also satisfied for this question. Okay, na? After that, now applying the row operations with respect to R1. With respect to R1. That means what? That is R2 tends to, with respect to R1, I'll make it as R2 first element and R3 first element are zeros. That is R2 tends to R2 minus 3R1. Once observe the previous slide, here I'll make it as this 3 as 0 with respect to 1. That means R1. That means what about the row operation for that? R2 tends to R2 minus 3R1. If you are applying that, definitely it is equal to 0. And similarly, I'll make it as R3 first element as 0 with respect to R1. Then what about the row operation for that? R3 tends to R3 minus 2R1. R3 minus 2R1. After applying the two operations, then there is no changes in the first row. That is 1 minus 3 minus 1. And for using with R1, I make it as R2 first element as 0. The row operation is R2 minus R3 1. Then 0, 1, 1. And the 0, 7 and 7. And the next row 0, 9 and 9 with respect to these two row operations. Okay, with respect to these two row operations. After getting this, I'll take it as here once observe in the R2. Okay, after using R2 tends to R2 minus 3R1 and R3 tends to R3 minus 2R1, then the matrix will be reduced as 1 minus 3 minus 1, 0, 7, 7 and 0, 9, 9. Okay, once observe there in that R2 and R3 row, I'll take it as, okay, common 7. Okay, I'll divide with R2 with 7 and R3 with 9. Okay, R2 with 9. Then we get the matrix 1 minus 3 minus 1. This is 0, 1, 1 and this is 0, 1, 1 after taking common 7 and 9. Okay, next. Next, after this, that is 1 minus 3 minus 1. This is 1, 0, 0, 1, 0, 0. Okay, now I am using that next row operation. Sorry, this is 0, 1, 1, 0, 1, 1. From that I am taking R3 tends to R3 minus R2. From that is 1 minus 3 minus 1, 0, 1, 1, R3. With respect to R2, I'll make it as R3 0, that is 0, 0, 0. Therefore, from that, here completely R3 row as 0. Okay. Is there any possibility to make R2 elements are zeros? No. Therefore, once observe here, below the diagonals are equal to 0 with respect to the row operations. So that echelon form all conditions satisfied. Therefore, the given matrix is in echelon form. It is in echelon form. It is in echelon form. Therefore, number of non-zero rows. Number of non-zero rows. How many there? 1, 2, 3. Therefore, what about the rank of a matrix? That rank is equal to 3. Okay, this is the concept of the echelon form. Next class we will discuss with the same concept with the different examples. Okay, now what we are discussing today? We are discussing today row and column transformations and basic concepts of rank and another form of the for finding rank of the matrix for the another form is echelon form. Okay, again I'll repeat with the same concept with some other examples. Thank you. Thank you for all.
Like, share and subscribe. Hit the bell icon for more updates.